So, okay, good morning, everyone. And today we will talk about two things. The first of all, our agenda will be talking about, we will talk about something called Anvil and Open on Demand. And at the end, we will talk about introduction to Open Science Grid, or OSG. So about the Open on Demand, about Anvil, we will talk first about what's a virtual machine, what's Anvil, use cases for using Anvil, how to access Anvil, and how to use Anvil. Unfortunately, we will not have a demo for today's session, but I'll guide you like where you can find all the instructions or detailed instructions for setup an Anvil step by step. So Anvil actually is the Holland Computing Center cloud computing resources. So Anvil built based on OpenStack, which is the most well-known program for cloud computing, and it's OpenStack. It's a free and open source software platform for cloud computing, as I mentioned, and so we have our Anvil built based on this software. So Anvil, it's used for creating a virtual machines. So if you want to create or if you need a virtual machine for your work, so we provide this service. So you can create your own virtual machine. You can have full access to it, and even you can attach some volumes to that virtual machine. So what, like for the ones who doesn't know what's the virtual machine, it's, you can think about it as a computer within a computer. So the virtual machine, if you have a computer with the operating system or specified operating system, which is maybe like Windows or Linux or Mac OS, so you can create like a new environment or a separate new environment that you can play with and work with separately from your own machine. But this virtual machine or this environment built based on the hardware that you have or the resources that you have in your, for example, device or machine like computer. And for our machine, for example, like if you have, for example, let's say a Windows machine and you want to use, for example, a different operating system, but you want to keep your own operating system or the main operating system that you have in your machine. For example, like if I have Windows and I want a Linux environment, so I can, using the virtual machine, I can create a virtual machine environment that will have, a Linux operating system, and like all operating systems, for example, and any software as well. Operating systems and any softwares, they need the resources. They need like computational resources, like CPUs. They need memory, which is RAM. So those resources, you need to provide them to the virtual machine so it can be used for this environment. So in the virtual machine, in your machine, you will specify those resources and reserve them for your own virtual machine, for example, which is if we want to use Linux operating system. So and you will have a full access and root access to that virtual machine. So in this case, so you will have two, let's say, like environment that you can work with within a single machine. that you already have, maybe more. Like you can create 3 or 4, whatever, depends on how much resources or available resources that you have in your machine. So that's why we provide here in Holland Computing Center, we provide the resources that you can use to create your own virtual machine. It can be 1 virtual machine, 2 virtual machines, and there is like actually a limit, and we will talk about it in the next few slides. So virtual machine is shared hardware that is partitioned. So you divide or partition the hardware that you have and isolate it from each other for each virtual machine you create. And it can contain a different operating systems, as I mentioned. So it can be you have, for example, your own machine, maybe, or the machine that we have. You can have a virtual machine which is based on like a Windows operating system or different flavors like operating systems. For example, another virtual machine I have, which has CentOS operating system, different flavors. For example, I want Windows 10, Windows, XP, whatever, to create those virtual machines. Depends on your needs. So there is some basic terminologies we want to talk about it. We use it a lot and most frequent when we are talking about, virtual machines or Anvil in our Holland Computing Center. The first terminology, which is called project. So projects refer to a unit in the ownership. So which we refer to it like in HCC, in Holland Computing Center, as a groups or HCC groups. So each project equal to or refer to HCC or Holland Computing Center group. So everyone in here has their own account, and this account, it belongs to one of the groups. So when you look into Crane, for example, you go, for example, to your home directory, you go to home directory /home / the name of your group, then / the username, right? Or user ID that you are using for accessing Holland Computing Center or resources. So when we talk about, when we called about project, that means it's a group, so which is your group. And there is like a terminology called image. So we'll use it a lot. And you will see it when you are navigating our, Holland Computing Center or our documentation on website. So the image refers to the software. So when you see something called image, that means it's the software, which is everything is needed to build or to create your virtual machine. It was like usually like it's refer to operating system, for example, if it's Windows or Linux, etc. And there's a terminology called a flavor, which is, for example, the resources that is needed for your virtual machine to be able to create it or to reserve those resources. Like we refer to like the number of the CPUs or, how much RAM do you want for your virtual machine. So if I said like I want a virtual machine flavor with like 4 CPUs and maybe 4 gig of RAM, for example. And there's an instance. The instance is the virtual machine itself, how it's which is equal to our image plus the flavor. So the image that we needed, for example, I need an image, which is the software, which is like, for example, I want to create a virtual machine or an instance called like X, which has Windows operating system or Windows 10 operating system that has a flavor of like, for example, the flavor with like 4 CPUs and, for example, 8 gigabytes of RAM. So the image plus the flavor, the hardware plus the software in a virtual machine itself, or called an instance. So if I want to create a virtual machine, I don't say that I want to create a virtual machine. I want to create an instance. This is how we refer to virtual machine itself. We call it instance. And there is a volume, which is, you can think about it as an extended storage that you can attach to your instance. For example, I want, you can think about it as an external hard drive that when you attach to your laptop, in this case, on the Anvil, environment, we call the volume. So I have an instance that have, for example, 4 gigabytes storage, and I want to attach 100 gigabytes, attach a volume with 100 gigabytes of storage to it. So the thing is about the volume, as you can see, it's a separate storage. So when you attach it to your instance, if you delete the instance, that the volume or the data inside those volume or stored in this volume, it's going to be like can be retrieved. Snapshot, the last terminology, which is called snapshot. The snapshot means the snapshot of an instance means if you want to do like a backup to this instance. So usually, like after a while, like using the instance, so you need to do a snapshot or to backup to this instance. So we call this terminology called like snapshot. So to use Anvil, accessing Anvil. So first of all, you need to have an access to Anvil before using Anvil. And this access can be provided from our Holland Computing Center. So first of all, you need to request to access Anvil. And it's a simple form as the form that you used to apply for, similar actually to the one that you used to apply for creating an HCC account. So we have another form, especially for Anvil. So you need to, just apply or let's say fill out the form, and this is the form. I bring it to the window. So in the request Anvil form, you can see here, you can just specify the group that you are and the research to be conducted to Anvil and why you want to have access to Anvil or why you want to use Anvil. And then you submit. After approval, we will provide you the access to Anvil. Then you can follow the steps to create your own instances. We have a limitation for providing the resources for per group. So each group has a limit of 10 instances. They can create up to 10 instances, and those instances, like, they have a limit with the virtual core, because the resources that we have, it's limited, so we can't provide unlimited resources to create whatever instances you want to or you need to. But like, there should be a limit, and the limit is 10 instances per group with 20 cores and 60 gig of RAM, and the amount of the number of volumes, the numbers of the volumes that you can attach, which is 10, with the capacity of 100 gigabytes for the storage volume. So, so we can actually, in some cases, if it's needed, we can give exceptions and expand those limits for some reasons. If you have like a reasonable reason that you really need, and you can email us at HCC support @unl.edu to request, so increasing the amount of these resources for the instances. So then after you apply for an Anvil, access to Anvil, when you get approved, then next step is creating your own virtual machines or your own instances. As I said, different flavors. It doesn't matter, like flavor with, let's say I want to create a Windows or a CentOS-based instance. So the steps that you need to follow, which is first of all, you need to connect to Anvil VPN. So Anvil VPN need to be accessed via something called VPN, which is you need to connect. I'm sure most of you know what's the VPN, and we'll talk about it, how you can get this software, probably like the Cisco AnyConnect. You need to download Cisco AnyConnect, which can, if you are out of campus, so you can connect to let's say a university environment network that you can access Anvil with, but it's not accessible like if you are not using a VPN. Then after that, this is like every time you need to access your instance, you need to connect to the VPN or Anvil VPN. Then there is like you need to create an SSH keys, which is a private key and public key, and this is will like provide you an access to your instance, as in like think about it as username and password, but this is like another way for authentication, and this done just one time. So you need to do it just one time for create an instance. Then after that, after you create an SSH keys, then you need to create an instance. So you will be able to create your instance, and for each instance, you need to provide a private and public key. And when you create an instance, then there is a steps that you need to follow for creating instances, and maybe you can attach a volume to it as well. Then after you're done with the create the instance, so you can connect the instance at any time you want. So these are the 4 major steps, but like each step has sub steps that is provided from our websites. So we don't have time to talk in details about those steps, but they are provided from our websites, like in detail, like step by step with screenshots as well. So creating a virtual machine or creating an instance, as I said, like if you want to connect to this instance, you need to use an Anvil VPN. So you need to install something called Cisco AnyConnect, and why we use a VPN, or we require the VPN to be used to access your instance, because this is like a security issue. So this is one, let's say, kind of steps that we require to take to increase the security. So the VPN, or the name of the VPN, like when you install the Cisco AnyConnect, you need to like Cisco AnyConnect can be accessible here, or you can find it by the VPN. You need to install the VPN Cisco AnyConnect, which is provided for UNL users. and then after that, for the HCC users, like you just like click to this link and you download Cisco AnyConnect. Then like you can download it as a zip file, or like we have different versions with different operating systems that you use. And it's just like as in installing any simple applications to your laptop or your desktop. The other thing, after you connect, so you need, after you install the VPN, you need to use the Cisco, like, or the VPN, which is anvil-vpn.unl.edu, to be able to access, to connect to your instance. So this is the VPN address that you need to provide in your Cisco AnyConnect. Then after that, it will ask you about your HCC credentials, like your username and password. Then you will be able to log into the VPN. Then after that, you can access your instance. So you need to create an SSH keys for each instance that you create. And like it's kind of, this is the authentication that will provide you or authenticate you to, access your instance. So the thing is, there is a question. So any link today? Just I'm reading some questions. There's no links actually today. We are not gonna, have, for example, link for the command history. So, as I said, SSH keys, it's an like an authentication used for authenticate you to access your instances or Anvil instances. When you create, think about it, is like they're called, like there's two parts of the SSH keys. There is a public key and a private key. So when you create the public key, that's, like the identity of the instances. Think about it as like a unique ID that is provided for the instance, while the private key needs to be very secured. So think about the private key, it's your password. So you don't share it with anybody, but like the public key, it's okay. You can share it, and shouldn't be that, a problem to share your public key. But the private key, it's very important to keep it secret. So, and you treat it as your password, because this is the only authentication that you need to access your instance. So when you want to access your instance, the good thing about the SSH keys, which is the public key and the private key, when you just like SSH to your instance, it will save you, like, maybe doing your authentication every time, like your username and password. You will directly recognize this laptop, it's your laptop, and it can be accessed your instance or the Anvil instance. So it will access it directly. So since your private key is very important and you have to treat it as your password, you need to keep it somewhere, because it's like a long string that it's provided on a file. So you need to keep your private key in a secure location, or if you want to save it, like you need to save it like in a secure location in your laptop. So the instances that you can create, for example, I have an Apple or like Mac OS, operating system or Mac operating system, and I want to create, I can create Linux instance or Windows instance, etc. And I can access, connect from any of the operating systems, this operating system, which is Linux, Windows, and Mac OS. So I can connect to, for example, to my Linux or CentOS, for example, one flavor of Linux operating systems or Ubuntu. So I can access it from Mac OS to Ubuntu, and from Ubuntu I want to access to Windows instance. So this cloud-based virtual machines that can provide you this ability to access your instance at any time from any operating system that you have or you created. So the available instances that we have on our so the instance needs to have an image, right? This image is like the software that you need to have for the instances that we have. You can create instances on the Anvil, different flavors, like you can have a Windows 10 with Mathematica or MATLAB or SAS, for example, if you want to use one of those, or Linux, for example, we have CentOS or Fedora, Ubuntu, and there's like different more flavors of the instances. So again, this is like just an email again and again. If you have any problem or you face any issues while using or creating your instances, don't hesitate to send us an email to hccsupport@unl.edu. We have an open office hours every week on Tuesdays and Thursdays from 2 to 3 p.m. I will share with you now, like if you go here again, all the steps as I mentioned for our guidelines on how to create an instance. For example, it's provided in our documentation or our website. So as you can see here, so this is our website. If you go or navigate in our documentation, and there is an Anvil HCC cloud, as you can see here. So first of all, here is, for example, it's how to add your SSH keys, how to add your SSH keys. And here's like, for example, Anvil instance types that we provide. There is different types of Anvil instances. There is like small, medium, or large, or X large, or 2X large, or 4X large. What does this mean? This means is like the resources that each instance can be used. For example, if I want just one CPU and 2 gigabytes of memory, that called like a general but small instance. The medium, it's like one CPU with 3 or up to like almost like 4 gigabytes of memory, and the hard drive or root disk has 40 gigabytes. This you can create up to 16 CPUs with 60 gig of memory and 160 gigabytes of storage. This is called the general purpose instances. So this is the category for general purpose. If sometimes you need like a high memory instances, that means like we need more memory for your instance to do more memory bound calculations. Then we call it in the category, there's a high memory instances, which is up to 120 gigabytes of memory and 160 gig of disk and 16 CPUs. As you can see, those are the similar. the root disk and CPU are the similar. The only difference, because it's a high memory, we concern about the memory, so it's going to be increasing the amount of memory that you need. And there is compute instances. Here, the compute instances, we increase the amount of CPUs, as you can see, up to 32 CPUs. So this is just the information about the instances that you can create. So it's very easy. For example, if you just search Anvil, HCC UNL, so you can see here the first thing you will see, it's Anvil Cloud. So here is the the guidelines directly, how like it will guide you how to create the instance, or our terms and step to access. So for example, if you want to access, as I said, first of all, you need, these are the all steps that we talked about. You need to request access an Anvil, and this is a link. And this is the limitation. As I talked about the limitation for the groups. If you click to the limitation, this is the limitations. This is, if you click to this link, it will, guide you to request an Anvil access. Then here is the steps for creating SSH keys. And it's different. That's why we don't go in details, because we don't know which operating system you use. Sometimes you use Windows, sometimes you use Mac. So these are step by step on how to create an SSH keys, the private and public keys. And as you can see, it's detailed ones, and step by step. It's very easy to follow, and you should be good, following those instructions. And this is for Windows, this is for Mac as well. Like we have, detailed, screenshots as well in our documentation. Then connecting to Anvil VPN. This will give you how you connect to the Anvil VPN. And here's the link. If you want to download the Cisco AnyConnect to have able to access our VPN to our network, which is, as I said, anvilvpn.unl.edu. As you can see, after you install the Cisco AnyConnect, it will give you, when you run the Cisco AnyConnect, you need to write the VPN or this address, let's say anvil-vpn.unl.edu. Then in details as well, is going to ask you about HCC username, HCC password, then, like your credentials. And then after that, there is a second password, which is like you enter 1 or 2 or 3, just, to get the notification for do. After you connect to the VPN, you need to, create the instance. So if you, you need to add your SSH keys. And these are how the steps, how you can add it to the Anvil instance, or to your, to your Anvil account. Then connect. When you want to connect your instance, so these are the steps for each different operating system. So if you are using Windows or Linux instance, how to connect, like if you want to connect from a Linux to, like you want to connect to Linux instance using Mac operating system. Or if you want to connect to Linux using, like if you have an Linux instance, I want to access it, and you want to access it using, if you have a Windows machine, so using SSH. So this is the steps as well. So all the steps are provided here, like in in screenshots. So step by step. So I recommend you guys, if you want to use Anvil, just to, go and follow those steps or these steps one by one or step by step. And this will provide you on all the information that you need for accessing and creating virtual machine instances with different, flavors. I think that will be all about our first part of the session, which called Introduction to Anvil, or how to create your virtual machines. So please, ask any questions regarding this, and or maybe you can write it in the chat. So please let me know if you have any questions. Okay, so since most of you guys, if you have any problem, just put the X mark beside your name, so we can help you with it. As you can see, when you log into your Open on Demand using your browser, so you can see there is let's say a taskbar that has Open on Demand. There's files, jobs, clusters, interactive jobs, my interactive sessions. Also, you have here in help, you can see here, there is, if you wanna, there's an online documentation for Open on Demand, or even if you want to change your HCC password or reset your password, so you can do it using Open on Demand. So it will open the link in here just to change your username and password, as you can see here, if you want to change your password. So if you want to log out, you need to log out from here. But if you log out, for example, let me log out. If I log out, and again, if I do Crane, it's not logged me out. So you need to close your browser. So you need to quit the browser to be able to log out directly. As I said, there is here, as you can see, a message from Crane, and this message, you can see it, which is the same as one that you can see when you log into Crane using a command line interface. The first thing we will talk about is the files. If you click to the files here, as you can see, we have three, let's say, partitions, or directories you can log in, right? Or main directories. You have your home directory, and you have your home directory, you have your work directory, and you have the common directory, right? The common, which will be accessible from Crane and Rhino, by Crane and Rhino for both. For your work directory, it's accessible from Crane because I'm in Crane, and for my home directory, which is accessible from Crane as well. So if you want to go to your, for example, to your work directory, I just click to the work directory here. It will open a new tab, and as I can see, or you can see all the files that is stored, and the files and directories are stored in your work directory. And as you can see, here's the path. So I am under work Swanson, which is my group name, and this is my username. And these are all the files, and as you can see, here's my folders as well, or directories. So again, here, for example, I want to have some files, for example, let me see. So for example, I have a data folder over here, and it has directories and files. So as I mentioned before, so we can create a file. For example, let me add the new directory here inside of this. So I will add here, as you can see here, there is go to, there is open a terminal, new file, new directory, and upload. So if I go here to a new file, we said we will create a new directory. Let's create a new directory, which is a new directory. and we will call it test, for example, and okay. As you can see, we created a directory called test. And the command line is going to be make directory command, which is equivalent to this. But this is as using like a graphical user interface, right? So let's get inside, double click to it. We will get inside of it. We will create a file. Let's call it test1, which is the file, right? Test1, and this is a file. It's not a folder. As you can see, we created a new file called test1. So if you want to edit this file and add text on it, so I will click to this file, and as you can see here, there is a view. View is just like you need to view. If I click to view, it's an empty file, as you can see. And to edit and add text, you just click to the edit. It's open in the editor, or welcome to HCC workshop. Okay. And then after I finish, for example, writing whatever sentences or edit this file, I need to save it. I save it from here. So then I close the tab. I came back in here. So if I want to view it, so as you can see, we'll come to HCC workshop. So here how we edit the file. So if I want to copy this file, for example, we click to the file or directory that we want to copy. We copy it, and then we will paste it. Then it says like, here is the paste. So if I want to change, for example, if I want to create another directory, this too. So, oh, sorry, another, yeah, directory. I want to copy this one, copy it. Inside this too, I will do paste. So as you can see, it's pasted over here. So sometimes it takes time. It depends on the connection. So as you can see here, if I view it, it's the same file. So if I have, here you can go up. So for example, here's multiple files. I can select all or unselect all. So for the files, there is something I want to tell you. So there is sometimes when you click for sometimes here, sometimes if you want to go to a special directory, for example, I'm in here, instead of going up by using the directory, I just can, if I go inside this and then inside include. So as you can see, I do not go up and up, or like up level directories, then up level directories, or 3 or 4 directories. So then after that, I can just like click to, if I want to go to my home directory, I just click Tanash, and then it goes back directly to the pad that I just clicked. Something else, sometimes there is some hidden or dotted files, as you can see here. There is a checkbox. There is a conda. If you have a conda environments you created, or some dotted files, configuration files, so you can see which is started with dot. So using this checkbox, as you can see here, look, as you can see, all of those dot files showed on my screen. So, and here as well as show on mode, so it gives you more information about the permissions and the owners, and the data created. For example, like this directory, it's a directory which was modified in the last day of the last modified, and who's the owner, and this is the permission for this file. So something else you can do, it's which is a very important and very useful actually. Just uncheck those, and I'll go to my directory here. So, which is upload and download. So if you want to move some files from your own computer to your HCC resources, usually what we use, which is SCP, right? Or we talked about SCP before, and we talked about Globus Connect, right? To move files. Those are the most reliable and good ways to move your files. If you have a big files, we highly recommend you to use Globus. If you have small files, you can use SCP, or if it's like a small files as well, you can use Open on Demand. So if I want to upload some files from my computer, so I can, there is an upload in here. I click to upload. It shows no file selected. So I need to select the file. I click to choose files. And then after that, I can, let me choose one of the files. I can, for example, oh, this is a big file. I can choose any of the files, for example, this one. So I can upload, and as you can see, it's uploaded in here. So as you can see, it's uploaded to the directory that I am in, which is home Swanson Panache, which is going to be different than yours. Yours is going to be your home, then after that your group name, and then your username. So you can, choose any of the files that you want to upload. But again, this is supposed to be like small files, not really big files. The size of those files shouldn't be a big files. So if it's a big files, you will have a problem like uploading those files. So you should use Globus. Something else, if I want to download one of the files, I want to have, if you have some results like from your HCC, you want to download it to your machine. So again, there is 3 ways. Like SCP, there is a Globus, right? You can download, as well as you can download it directly using Open on Demand. So if I want to download this file, for example, my wave.m, so there is a download button here. I just click the files or how many files I want, and then download the files. As you can see, it downloaded my file as here. So it downloaded to my current machine right now. So any questions? I think we discussed everything in here in just the files till now. Okay, so there is a question on the chat box which said, can you show an example on how to run a program on Open on Demand? Yes, we will talk about it in a little bit. Just keep tuned. So again, we finished the files. Now we will talk about the jobs. So in the jobs, we will talk about how you can submit a job using Open on Demand. So there's 2 things. There's an active jobs, there's a job composer. What's the difference? The active jobs, it's the way that you can see your jobs or running jobs on the cluster or the submitted jobs, for example, which is equivalent to if you submit a job to a cluster using command line interface, you will have the SQ account, right? SQ-U and your username. It will show you the status of your job or submitted jobs. Here, since I don't have any jobs till now submitted, I'll see it. You can see it here as like, if you don't have any jobs, you will see it empty. If you have jobs, you will have like you can monitor those jobs using using this window. As you can see here, here all clusters or a crane, because we have the crane, it's just going to show you just the crane. The other thing is your jobs here. If you click to here, there is an all jobs. If you click to all jobs, this is all jobs that is running and pending or deleted, or the submitted jobs in the clusters. So as you can see, there's an ID, there's a name, user, account, and time, queued, and here's the important, which is the status. For example, this is a queued account, a queued job, and this is a running. These are completed jobs. So you can see here. So if you want, because this is all the jobs, if you want just your job, this is equivalent to SQ command. While SQ-U, your username is going to be your jobs. So I don't have any jobs. So this is for the active jobs. Now it's a job composer. Job composer will tell you or guide you how to submit a job using the OnDemand. So let me delete this. Sorry, and delete this. So okay. So you will see it as this. So you will have it as this. This is a guidelines or tips how you can use it. And then first of all, you need to create a new job, and you can use it from the template, and you can edit it and submit it to the cluster. So if you click next, this is just the tips that will tell you how to use it. Okay, this is the last one. So let's create a job and submit it on the cluster and see how we can monitor it and get the results. So first of all, you need to create a new job. So there's two things. There is like a default template, which is the default template that used for creating a job, or from a template, which is I recommend is like using from a template. From a template, these are templates for submitting jobs in different, different applications. We created those common, templates. So as you can see here, there is a show in here. You can show how many, templates you can see on a screen. It's 25 or, 50, for example. It depends on how many templates you want to see on the same screen. So as you can see, there's a Python job, there is a general job, there is Abacus, MPI, there's a Blast. There is the most common applications jobs. And like as you know, there is like a jobs, every job different, use different command for submitting jobs. Depends on the application that it used, right? So that's why we have a template for most of the application used. For example, if you want an R job or Python job, whatever job you are, using, maybe you can find it. So if your application, you can't find your application, you can use a general job, which is the default job that is submitted, and add your files, edit this script, and submit it as your job. So you can name your job as you want, and then after that, you can edit it based on the application that you want to use, and then after that, submit it. So for example, if I want, let's do an example. If I want to do like a Python job. So a Python job, as you can see here, create a new job. So I can change the name. For example, I want to do HCC workshop. Okay. And the cluster is a Crane. And these are the folders or the files already inside this job. So you can see here, this job has, it's first of all, this template is stored inside this location. Okay. And then after that, and inside this folder for this job contains three files, which is hello world.python, manifest.yaml, and python.submit. So I can open this directory if I click here. As you can see, here's the hello world.python. I can edit it. So if I want to view it, I can view it. This is the Python program I want to to run, which is going to have a for loop from 1 to 5, and it's going to sleep 60 seconds, and it's going to print, if it's 1, it's going to print 1 minute elapsed, then 2, 3, 4 till 5 is going to like minute have elapsed, and then it's going to at the end print hello world, right? So I don't want it to be asleep for 60 seconds. This is like I want to edit this one actually because it's going to take a long time. I'll click to edit. I'll edit this file. Instead of 60 seconds, I'll make it just 5 seconds. Okay. So it's going to sleep 5 seconds. If it's 1 in the first loop, it's going to print 1 minute has elapsed. For 2, 3, 4, 5, it's going to go to the else and print minute has elapsed. Then it's going to print hello world. So then I need to save it. So I'll choose different template because this template does have, I think it has a problem. Not sure this is, we'll use, for example, let's use a MATLAB. Let's use this MATLAB for a MATLAB job. We will open the directory and matlab.submit. We will edit this file. Sorry, not the submit. So this is going to be, this is the invert rand. This is the one we can choose. And we can, let's do, I need to close this one. So it depends like on which application you want to use. So if it's a MATLAB, so this is from my side actually. The Python one like has like the file has missing file, which is from my side. So I'll choose a different template. I'll use, for example, like to run a MATLAB if I want to edit it. So for example, if I want to add a comment, for example, here I want HCC workshop example. Okay. Then after that, I can save it. I don't know why in the saving it does not. Never mind. So you can edit it by yourself. I don't know what's going on here, but you can edit it. And then after that, after you are done editing this, oh, I know why. So here, like, for example, let's do the Python job again. So here, let's do my job. Let's do my job. And then you create yeah, like it works fine for me. I can save after editing. I don't know why it's not saving or like not editing in my side, but usually you can do it. So usually you can do it. So as I told you, like this error, it's from my side. It's not your side. I don't want to, like, because of the limited time, I don't want to deal with it right now. So yeah, after you create a job, so in here, you can edit the files. So the thing is, sorry. So yeah, like the thing is the error that we had because we tried to edit the main template, which is we can't edit, right? This was my mistake. Sorry for that. So the thing is you can edit the file after you created the job. So I created my job, which is my template. So after that, if you can see it over here, after you just create this job, you can edit the files using the edit files button. So if you click to the edit files, this is the hello world. I can edit this one, and instead of 60, I'll put it 5 seconds. And then after that, I can save it. Now it's saved. So if I go back, hello world. So if I view it, it's going to be instead of 55. So now after creating this one, my job, let's say, and this is the submit file, and I can view the submit file. The submit file is going to ask for 10 minutes, number of processors, it's 4 processors, number of nodes, 1 node, and memory is 10 gigabytes. And the error is going to be MATLAB_job or whatever. So this is for MATLAB, sorry. This is for Python .submit if I want to view it. So it's going to ask for 1 node, 5 gigabytes of RAM, and 10 minutes, right? And it's going to do module purge, and then it's going to load the Python 3.8. And then it's going to execute hello world.python, which is the file that we just edited, which is hello world.python. So if you want to edit the submit, so you can the submit script, you can edit it. For example, instead of 10 minutes, I want to do it 9 minutes, for example, and then you can save it. So here, what you can do for submitting jobs. Now my job is ready, and I want to submit this job. So I click to my job, and then after that, I submitted my job. After you submit my jobs, you can see the status is changed to running. And if I go to the jobs in here, this is my jobs. If I go here, for example, and refresh the page for the active jobs, you can see this is the job I submitted, which is this is the ID job, and this is my username, my account or my group, and now it's running. So in the state of running, so I can check it again. Now it's completed, right? So the results I can see, as you can see, the script location. So it's going to be under .open on demand in your home directory, in your work directory, sorry, under .open on demand, there is a projects default and number 1. So if I go here to the files, this is work directory, and I need to do the show dots and open on demand and projects default under 1, as you can see. And as you can see here, these are the Python scripts and the Python program that I submitted or I executed. And here, as you can see, there is an error and there is an out file, as I can view. So the error is supposed to be empty, because if we have no errors, it's going to be empty, and our job is completed. The .out file, as you can see, here's the output of running this program, which is in the first one, as we said, 1 minute has elapsed, 2, 3, 4, we have minutes has elapsed, and then after that, at the end, it says hello world. And this is how we submit a job using Open on Demand. So again, you can also create your own templates. You can edit the templates. So it's very, easy and convenient to work with using graphical user interface. Okay. So now we will talk about, for example, if I have this job now submitted, I can as well as delete it. For example, if I want to delete this template for myself or this job, so I can delete it, and it's now deleted. So again, after you create a job, you can create it as your own template. So you can use it again and again for some other jobs. So this is gonna give you just more options to deal with. We have 10 more minutes to talk about or less. So the last thing, in the cluster, you can have a credential access. So here, as you can see, it will open using the browser. It will open like, command line interface, or shell for you to work on if you want to use the command line interface for our Crane. So for example, I do ls, so I can use it as a shell to write the commands. So it gives me as well as ability to work with command line interface or the shell. Okay. Now we have an interactive jobs. In the interactive jobs, as I mentioned before, we have some applications that are installed and you can work on with graphical user interface. First of all, before that, we have a desktop. The desktop is going to give you a graphical user interface for our cluster, for our operating system, but you can use an instance. So if you click to the desktop, you need here to specify the resources or the instance or the interactive jobs. Like when you click to the desktop, it will create an interactive job for you, but running the desktop on it. So number of cores can be up to 8. So I'll choose it like just like, this 2 cores, and how long you want this instance to be run. If you wanted 2, 3, if I choose like 3 hours, the maximum is 8 hours. And how much RAM do you want? So maximum is 32. I'll choose 2 gigabytes of RAM. And here the queue short is it's exactly as you submit an interactive job. There is like a short and normal queue. Short is going to be usually is going to take less time to execute the instance. But this is using like the normal use the batch queue, which is the normal batch that we submitted the jobs. And the partition is going to be batch. If you want to use a GPU for this instance, for this interactive job for your desktop, you need to specify a GPU. So, but we need it for a batch for CPUs. But if you want to use GPUs, you need to use a GPU queue here or partition. So the reservation, if you have a specific queue that is associated with your group, you can use it. Grace here, if you want to use GPU, you need to specify a GPU here, but since you are using CPUs, we don't need to. And the constraints, if you need to use a GPU, a specific type of GPU, for example, V100 or some other types of GPU, you need to specify the constraints over here. Then this email, it will give you an email when the instance is ready or to use the desktop, and you can notify you when it starts. I don't want to do this. So then we click to launch. As you can see here now, it's creating the interactive job, but it's not running yet. So we need to wait till associated the resources. Now, as you can see, it changed. Now it's it can create or specify those resources for you and allocate those resources. And it's, as you can see, time remaining. It's 2 hours because we specified for 3 hours, 2 hours and 59 minutes. And then we can launch a desktop. When you launch a desktop, so as you can see, it will give you a graphical user interface for your a desktop, like for your HCC resources, which is, for example, now we are in the Crane. This is going to be in the Crane. You can navigate. You can use it as a CentOS operating system. So after I finish with this one, I deleted. We use this one sometimes if you want a browser in your use a browser, for example, or some applications that you want to use, or see some of the results in graphical user interface. So you can use the desktop to view those results, right? Some of the results have the graphical user interface you want to see. You want to have some applications have an interactive, environment that you need to interact with. So that's why we allocate those or the desktop option. After you finish from this desktop, you just need to delete the instance. We highly recommend you, after you finish, to delete the instance, so you can free the resources that's being used. Again, in interactive jobs, we have different applications. You can use MATLAB, you can use Mathematica, we have SAS, we have Jupyter Lab, Code Server, we have which is called Project, RStudio. For the RStudio, for example, this create an interactive RStudio server. So I click to RStudio, and most of the applications are the same. So I click here and choose the version. For example, I want this version. R variant, I want it to basic. And then number of hours, number of cores, 2 cores, 1 hour, and 2 gigabytes of RAM. Again, here's up to 16. I can choose up to 8 hours and up to 8 cores. And partition or quality of service is going to be used is going to be short. Partition is going to be batch. And I'm not using any GPU, so I do not need to specify those unless I'm using a GPU. I need to change the batch to GPU and, egress to GPU. And if I need a specific type of GPU, for example, here's the GPU types. For example, if I want to specify GPU V100, I can write it over there, or GPU P100. So I can specify it. I can specify it on here on the reservation, on the grace. Sorry. Those can be on the job constraints. So on the graces need to be just a GPU. And then after that, I will launch it, waiting for resources to be allocated. And then after that, as you can see, here's username. It needs a username and password. Then you copy your password, you log into RStudio. So my username was Tanash, and I need to paste my password. I'm doing this because I want to show you how to access R. So this is an error message for previous sessions. So for example, here I have an R, for example, A equal 3, B equal 5, A plus B, let's see, is going to be it. So it's running, right? So after I finish this one, I need to close it and delete my instance after finish working on it. So in my interactive sessions, if you have more than one interactive sessions, if you click to more or my interactive sessions, you can see all of the interactive sessions or the active ones as a list on here. So you can delete or play with. So that's going to be all about Jupyter, Open OnDemand. Any questions? If you have any questions, please unmute yourself and ask.
All right, everyone should be able to see my slides now. All right, yeah, I just wanted to talk briefly. This discussion won't have any hands-on component or anything for you to necessarily try yet. It's just going to be a short introduction to the Open Science Grid. The Open Science Grid is another computing resource. So this is completely separate from Holland Computing Center, although we do participate in the Open Science Grid. But this is a different computing resource. If you find that Holland Computing Center resources aren't enough for what you want to do, and your jobs are a good fit for for the Open Science Grid, then this is something that you should consider. So I'm going to talk about what is Open Science Grid, who uses it, what is meant by owned versus opportunistic use, and what does that mean for you? And then some details about what are the characteristics of a quote unquote OSG friendly job, or what types of jobs work well on the Open Science Grid. And then a way for you to decide if OSG is right for you, if it's something you should look more into. And then I've omitted the hands-on component of this because we won't have time, but okay. So the OSG is short for Open Science Grid, of course. This is a nationwide consortium of software, service, and resource providers and researchers from universities and national labs all over the US. And it's a framework for sharing computing resources. So what does that mean for you? This is a way for researchers from virtually any US-based institution, nonprofit research institution, to be able to submit their jobs to run on clusters that are owned by other institutions and spread out all over the United States. And the result is that to a researcher, it looks like one large resource. You don't have to have separate accounts and separate logins for each of these different resources. You just have one account, and you can do it through your HCC account, actually, so you don't even need an additional account. And through the software that's provided by OSG, you should be able to submit your jobs out to this entire grid of computing resources. This plot just shows how much computing is done on OSG every hour, this shows over computing over one 24-hour period, and then over the last entire year, over 2.2 billion CPU hours were done on OSG. So this includes the researchers from institutions that own the resources, as well as researchers who come in from other, maybe smaller institutions that don't own OSG resources or computing resources of their own, and are running what's called opportunistically on the resources that are owned by those other larger organizations. And I'll talk a little bit more about that difference in another couple slides from now. So although OSG sort of originated in the high energy physics community, there's a lot of other fields of science that use OSG, and it's not limited in any way to the field of science. Even COVID-19 research is done on OSG now. And even in the humanities, as long as it involves computing in some way, it can likely be done on OSG. This plot shows total OSG usage over the last month. It's divided into virtual organization. So you can see the heavy users of OSG are CMS and Atlas. Those are high energy physics virtual organizations. A virtual organization is just like a research community. So most of the OSG use, you can see it's on dedicated resources. So that's an organization that owns their own resources and they compute on their own resources, but they also contribute a fraction of those resources to other users. About 15%, and this number fluctuates quite a bit depending on what the current load is on OSG by resource owners. But about 15% of the usage is opportunistic. So that means that a researcher from a small institution would submit their jobs to OSG. The OSG job scheduler would look for some cycles that aren't being used, some idle cycles on one of the resources, and would match the researcher's job to that resource, and that researcher's job could go and run there and create output files that are then sent back to the researcher. Okay, so OSG is a little bit different from computing resources like HCC. So HCC is considered a high performance computing cluster. OSG is considered more of a high throughput computing environment. It's better for if you have a workflow that consists of sustained computing over long periods of time. So that means you have lots and lots of jobs, hundreds, thousands, tens of thousands, or even hundreds of thousands of jobs that you need, and you submit all large batches of those jobs and put sort of a constant pressure on the queue so that you've always got 1,000 or so jobs running at any given time. And as as jobs exit and then enter the queue, the running queue, your workflow is just gradually getting done bit by bit. So it's better for serial codes that don't involve a large number of intercommunicating cores. So if you have jobs that can run on a single core or a small number of cores, and you have a lot of those jobs, those jobs might be a good contender for running on OSG. High performance computing, on the other hand, is great, gives you really great performance over relatively shorter periods of time. So if you need 2,000 cores to all run simultaneously and be able to communicate with one another at various intervals during the job, then that's like large scale MPI jobs. That's better for a resource like HCC as opposed to OSG. Furthermore, the resources of OSG are distributed, meaning they're spread out geographically all over the United States, and there is no shared file system. So when your job goes somewhere to run, it doesn't see the shared file system where that exists where you submitted it from. So if you're submitting it from HCC, from the login node on HCC, it will not see your job won't see your home and work directories or your common directory. So you have to make sure that you are able to ship your all of the components that your job needs with the job. So that includes the input files that it needs as well as software. Furthermore, as I mentioned before, the use when you use OSG in this way, the use is considered opportunistic. So your jobs have a lower priority generally than the resource owner's jobs, and they can be preempted or killed at any time by the resource owner jobs. But this really only tends to happen when you have jobs with long run times. And I'll talk in just a second about what that means, like how long. So you should make sure your applications are relatively short or can be restarted, meaning that they can restart where they left off when they were interrupted. Okay, so to summarize some specific numbers in relation to the last slide, the runtime should generally, for a good OSG job, be between 1 and 12 hours long. Ideally, it would also be single core or using a low number of cores, up to like 8 or so cores. Memory is also something that you can request as much memory as you need for your job. However, the smaller you can keep it, the more likely that a resource will be able to provide that memory to you. So, the smaller the smaller the resources you request when you submit your job, the more computing resources will be able to match your job. So you'll just have more nodes available to you to run your job. So try to keep that the memory and number of cores and runtime small. So in terms of software, like I mentioned, you need to be able to transfer your software with your job or provide it in some way. So using statically compiled executables that's transferred with your jobs, or package up your the environment that you need to run your job, including all of the libraries and packages that your job requires to run. And then so setting up, for example, a software environment that you can transfer to the job and set up on the worker node where your job runs. Also, you would need to only be using non-proprietary software on OSG, and that's just because of licensing complications. However, most of these are not really hard limits. So for example, 1 to 12 hour runtime is really just a guideline. Some jobs can run longer than that, but if a lot of your jobs run longer than that and get killed, you'll waste a lot of computing resources, and someone might kind of try to get you to stop doing that. So if your job is long, you'll want to make sure that it can support checkpointing. So your job would checkpoint itself partway through. Maybe it checkpoints every few hours, and then if it does get killed, it can use that checkpoint file that was created to continue running where it left off. We do also have some support for larger memory jobs. Like I mentioned, you can request as much memory as you want. It's just that the less memory you request, the faster your job will start running. We do have some partitionable slots, so you can request up to 8 cores. It doesn't have to be single core, but same goes for that. The fewer cores you request, the sooner your job will start running, or the more likely it is there will be a resource available for your job. And then, like HCC, we do have some modules available, software modules available. They're different than the HCC modules, so we might not have the exact same. In fact, we definitely don't have the exact same ones that are available for HCC. And we do have Docker and Singularity support. So if you're able to create a Docker image that can run your job, then we're able to use that on OSG. And the exception to the non-proprietary software rule is that you can run compiled MATLAB executables on OSG, but they do have to be pre-compiled somewhere else. So you have to compile it somewhere where you have a MATLAB license, and then transfer that MATLAB executable to the location where the job runs. Okay, so this is really my last slide, essentially. In summary, how do you decide if any of this is relevant to you? How do you decide if you really even need to use OSG? The first question you would ask yourself is, are my jobs OSG friendly? So look at that previous couple slides I had and answer those questions of whether or not you would even be able to run on OSG. And most jobs can if you make some changes to them. So we have to decide, is it worth making those changes? If not, if it's not worth making those changes, or it's impossible, then you certainly continue submitting to the HCC clusters. If yes, if you think you can make your jobs OSG friendly, or they are already, the next question you would ask yourself is, would you like to have access to more computing resources? Maybe you don't run that many jobs, and your jobs start relatively quickly on HCC, and you don't need to do the little bit of extra overhead that you would need to do, extra work you would need to do to submit them to OSG. In that case, just continue submitting to the HCC clusters. But if you have a lot of jobs and you're really not getting enough resources on HCC, please consider submitting your jobs to OSG. There is, like I said, a tiny bit of, hopefully only a tiny bit of extra overhead work that you would need to do. You'd need to, instead of using a Slurm submit script, you need to use a Condor submit script. So you would need to write a slightly different kind of submit script for your job, and we can probably help you with that. We can definitely help you with that. So please contact us if you think that you would like to run your job on OSG. We do have some documentation, unless it's somewhat dated and limited at this point, so it's something we would probably like to update soon, but we do have some documentation on our webpage of how to submit jobs to the OSG. And then for more information in general on the Open Science Grid and on the Open Science Grid and what sort of computing and what sort of research is done on Open Science Grid and how it functions, there's another link for that as well. That's all I have on OSG. Are there any questions? If not, please before you leave, fill out the small short questionnaire that Colin put in the chat. He put a link to it in the chat, so please fill that out so that we know these workshops are going for you guys. If they're too long, too short, too fast, too slow, you'd like different material, and let us know what we're doing well as well. Thank you for attending.